So I am continuing the session. So basic level definition is over. So the first gate question. This is asked in 2016. A1, A2, A3, comma A4 are four matrices which are of dimensions 10 cross 5, comma 5 cross 20, comma 20 cross 10, and 10 cross 5 respectively. Then the minimum number of scalar multiplications in the matrix product A1 into A2 into A3 into A4 using basic matrix multiplication. Okay. Solution. So here first A1, second A2, third A3, A4. If I have two matrices, I know how to multiply. A into B. Okay, first is A, second is B. If I have three matrices A, B, C, how can I multiply three matrices at a time? So I can do first A into B, then multiplied by C. Or some people first do B into C, then pre-multiply by A. Okay, if the brackets are not mentioned, you have several ways to find the four matrices. Okay, so four matrices in a single step cannot be multiplied. Taking two matrices only in that order. First A1 into A2, then multiplied by A3, then multiplied by A4. So total three steps to multiply the product A1, A2, A3, A4. Okay, so here first A1, A2, first A2, A3, there are so many cases. So that's why they are asking the question minimum number of scalar multiplication. Please underline. So case 1. I am taking as usual every normal people doing this way. A1 into A2. Second step is A3 into A4. Third step is product of the above two steps is equal to question mark. The question mark means how many number of scalar multiplications we are going to find. Okay. So here step by step. The first step is A1 into A2 gives. Please remember that order I told you. M into N into P. Okay. A1 is M into N. A2 is N into P. Then the number of scalar multiplications A1 into A2 is M into N into P. Please remember this formula. Okay. So here A1 is 10 cross 5. A2 is 5 cross 20. M, N, N into P. So gives 10 into 5 into 20. So 50 into 20,000 scalar multiplications. MULTIP means multiplications. So step 1 gives 1000 scalar multiplications. Next A2 into A3 into A4 gives A3 order is 20 into 10. Compare with M into N. A4 is 10 into 5. Compare with N into P. So M value 20, N value 10, P value 5 gives 20 into 10 into 5 which is again 1000 scalar multiplications. And finally, these two steps multiplied. Total 3 steps to find 4 matrices multiplication. That is A1 into A2 into A3 into A4 gives. So what is A1 into A2 order? 10 into 20. What is A3 into A4 order? 20 into 5. Just compare with M into N, N into P. Okay. So which gives 10 into 20 into 5. That is again 1000 scalar multiplication. So altogether, in this case, the 3 steps together adding, which is the total number of scalar multiplications, implies total number of scalar multiplications is 3000. If you ignore these verbal language, that English words, it is easy. Because as a teacher, I have to explain, I have to write each and every step. That's why I am writing like this. Looks like big procedure. Because of 1 mark, 2 marks, this is asking 2 marks only. And remember, some questions, even the 2 marks, which is a statement-oriented question, that is 1 line, 1 step, word answers. Some questions 1 mark, which is taking half page, full page, 2 pages also. The average time for each question is 2 minutes 45 seconds. That is almost 3 minutes. Okay. Some questions 1 minute, some questions 10 seconds, some questions 5 seconds, some questions 10 minutes also. Okay. So next, case 2. I am taking A1 into A2 into A3 into A4. This case, step 1 is A2 into A3. You know, brackets should be simplified first. In the mathematical procedures, there is a BODMAS rule. Brackets, step 1, simplified first. Next, OF off. Next, division. Next, multiplication. Next, addition. Next, subtraction. So always, inner brackets should be simplified first. In this case, how many scalar multiplications? A2 into A3 gives, this is A2, 5 into 20, 20 into 10. Compare with M into N, N into P. 5 into 20 into 10. So 1000. Next, A2 into A3, post multiplied by A4 gives, what is A2 into A3 order? 5 into 10. What is A4 order? 10 into 5. So compare with M into N, N into P gives 5 into 10 into 5. That is 250 scalar multiplications. And what is the last step? Multiplication of these 2 steps. That means this step pre-multiplied by A1. A1 into A2 into A3 into A4. So this A1 order is 10 into 5. This bracket order is 5 into 5 gives, looks like M into N, N into P. 10 into 5 into 5, which is again 250. So altogether these 3 steps, sum of these 3 steps implies total scalar multiplications in this case is 1500, which is very less than the case 1. Final 4 matrices multiplied in any order. First is A1, second is A2, second is, in any case, third is A3, fourth is A4. You will get single matrix answer. But number of scalar multiplication may changes. case 3. You are all well remembered about associative property. In case 2, in A2, A3, A4, I want to change the brackets. That means A1 is finally multiplied A2 into A3 into A4. So in this case, I want to do, that means the first step is A3 into A4. A3 into A4 gives, A3 is 20 into 10, A4 is 10 into 5, M into N into pi gives 20 into 10 into 5. That is 1000 multiplications. Next, A2 into A3 into A4 gives A2 order 5 into 20. A3 into A4 order 20 into 5. So looks like M into N into P gives 5 into 20 into 5 M into N into P. That is 500 scalar multiplications. Okay. Next. Finally, A1 into A2 into A3 into A4 gives, so A1 order is 10 into 5 and this order is 5 into 5. Looks like M into N into P. 10 into 5 into 5, that is 250. Altogether, total scalar multiplications is 1750, which is more than case 2, less than case 1. Case 4. A1 inside into A2 into A3 finally multiplied with A4. Question mark. In this first step is A1 into A2 according to brackets, innermost bracket, gives 10 into 5, 5 into 20, compare with M into N into P gives 10 into 5 into 20, that is 1000 multiplications, scalar multiplications. Next, A1 into A2 multiplied with A3 gives, so what is A1 into A2 order? 10 into 20. A3 order 20 into 10. Compare with M into N into P gives MNP 10 into 20 into 10. So this is 2000. Next, finally, A1 into A2 into A3 into A4 gives, so this order is 10 into 10, A4 order is 10 into 5. Compare with M into N into P gives MNP, that is 10 into 10 into 5, that is 500. Altogether, total multiplications is 3005, which is greater than all cases above. And the last case 5. So this is taking, by ignoring that English words, almost 3 minutes, 2 to 3 minutes only. Only case 1 taking more time, remaining use your mind calculations, step by step. Case 5. So in case 4, interchange A1, A2, A3 brackets should be interchanged. Associative property, A1 into A2 into A3 into A4. This is the last case. For 4 matrices, 5 cases. In this, the step 1 is middles, A2 into A3 gives A2 5 into 20, A3 20 into 10, M and P gives 5 into 20 into 10, that is 1000 scalar multiplications. Next, A1 into A2 into A3 gives A1 order 10 into 5, A2 into A3 order 5 into 10. Compare with M into N, N into P gives M and P means 10 into 5 into 10, 500 scalar multiplications. And final step, A1 into A2 into A3 into A4 gives, this order is 10 into 10, M into N, N into P, M into P order, refer matrix multiplication definition, A4 order 10 into 5. Compare with M into N, N into P gives M and P, that is 10 into 5, 500. So altogether, adding the three steps, total scalar multiplications is 2000. So 3000, 1500, case 3, 1750, case 4, 3500, and this is 2000. What is the conclusion? Hence, minimum in all above cases, that's why they asked the minimum number of scalar multiplications is 1500. Please write fast. So once again, for some people purpose, A M cross N order, B N cross P. So middles must be equal while finding the product in AB. Then number of scalar multiplications in the matrix product AB is M into N into P. Using this, we have done 3 steps in each case, okay, according to the brackets. The next type is some definitions. Number 1. In a general manner, comma, a row or a column is referred as a line or a vector so now onwards, two lines. That means either two rows or two columns depending on the situation. Two vectors. If I say somewhere or any question or any definition, that means it is indicating either two rows or two columns. Okay. The length, some people this is called norm. Of a vector x, generally vectors, column vectors, row vector denoted by capital X, capital Y, capital Z, etc. is denoted by so both sides two times of vertical lines. That is the symbol stands for length or norm. If I write one time both sides of a vector or a matrix, it is called determinant symbol. So this is the length symbol. And given by, how do you find length of a vector? Square root of sum of the squares of the elements. Okay. Square root of sum of the squares of elements in X. Next, a vector divided by its length. You know, length of a vector a bar, I bar plus 2j bar plus 3k bar, just vector calculus also. Same procedure. A vector divided by its length is called unit vector. Is called the unit vector or normalized, another name, normalized vector of X. Example, the norm of the vector four minus 2 minus 6 transpose is solution. So, it is square root of 4 square plus minus 2 whole square plus minus 6 whole square is equal to, because this is square root of sum of the squares of the elements, 3 elements. This vector is a column vector. This original row vector transpose. Row transpose is column, column transpose is row. Okay. So, this is square root of 16 plus 4 plus 36. That is root 56. If this is not in the options, 4 14s are, so 2 root 14. That is. Next definition 3. The dot product of two vectors x and y is denoted by x dot y and defined as x dot y is equal to either x transpose y or x into y transpose, just matrix multiplication. When both are row vectors, so the first one transpose row means column vector into row vector or row vector into column vector. Okay, so it is the matrix multiplication of a row and column vector or a column and row vector, that is called dot product according to either row vectors or column vectors. According to the given vectors, we have to take either x transpose y or x into y transpose, which is the definition of dot product. Okay, because matrix multiplication, the condition you know. Accordingly, that matrix multiplication condition, you have to consider any one of these, x transpose y or x into y transpose. Okay. Example. Let x is equal to 1, 2, 2 and y is equal to 2, 1, minus 1 implies x dot y. So, I can take x transpose y, which is nothing but this column transpose becomes row into column vector, that is 1 cross 3 into 3 cross 1. Finally, it is a 1 cross 1. Dot product is always a scalar. A scalar means it is a 1 cross 1 element only. So, 1 into 2. So, in the easiest way, I am telling corresponding elements multiply, then adding. That is first element into first element plus second element into second element plus third element into third element. So, 1 into 2 plus 2 into 1 plus 2 into minus 1. Or you can use x transpose y method also, will give same answer. So, 2 plus 2 minus 2, answer 2. That is. Definition 4. A set of S is equal to x1, x2, so on, xn. These are n vectors of n vectors is said to be orthogonal vectors or orthogonal set. If and only if, IFF means if and only if, each vector is non-zero and dot product of every two vectors is 0. So, a set having 3 vectors, 4 vectors, 2 vectors, any number of vectors, every 2 vectors, take every 2 vectors, find the dot product. If that dot product value is 0, that is called dot product of every 2 vectors is 0. Then the given vectors are called orthogonal vectors. That means forming a 90 degrees, that means comparing with vector algebra. A bar, B bar are 2 vectors. When do we say that they are orthogonal? Cos theta is equal to 0, that is theta 90 degrees, which is the angle between the 2 vectors also. Example. Let S is equal to, I am taking 3 vectors. With 3 vectors, x1 is equal to either row vector or column vector, 1, 2, 2, comma, x2 is equal to 2, 1, minus 2, comma, x3 is equal to 2, minus 2, 1. in this x1 into x2. That means pairwise dot product is 0. Pairwise means any two vectors dot product, every two vectors dot product. So first element into first, 1 into 2, second element into second element in x1, x2, correspondingly multiplied and adding, plus 2 into minus 2. So 2 plus 2 minus 4 is equal to 0. Okay. Next, x2 dot x3. In second, third vector, first element into first element plus second element into second element, etc. So 2 into 2 plus 1 into minus 2 plus minus 2 into 1, which is nothing but 4 minus 2 simplifies to 0. And finally, x3 dot x1 is equal to third vector into first vector. So first element into first element plus second element into second element plus third element into third element is equal to, simplifies to 2 minus 4 plus 2 is equal to 0. So pairwise dot product is 0. So therefore x1 comma x2 comma x3 are orthogonal vectors. So in addition to the pairwise dot product 0, that is orthogonal vectors, if length of each vector is 1, then the set of n vectors are called orthonormal vectors. Actually, these definitions are useful in some of the next definition, orthogonal matrix, in option wise, which is very fast. We can apply these conditions to decide which one of the following is an orthogonal matrix, or in vector spaces chapter also. Okay, that is in science subjects. That is a science, purely science subject. In addition to the above condition, comma, if length of each vector is 1, then the n vectors x1 comma x2 so on xn are called orthonormal vectors. Orthogonal vectors means dot product of every two vectors 0. In addition to this condition, if length of each vector is 1, then the given vectors are called orthonormal vectors. this definition related to minor of an element, cofactor of an element, adjoint of a square matrix, inverse of a square matrix, determinant of a square matrix. Before that, if there is a 2 by 2 square matrix, how to find the inverse, determinant in the fastest method from 10th class. Then other definitions can easily understand. Okay, and these definitions are very much useful when the questions are in options A, B, C, D. Definitely you have to learn the procedure for finding adjoint of a square matrix whenever your answer is option D. In that case, options methods take more time. Some problems whose answers will obtain by options method. Okay, some other problems if the answer is option D, there you definitely learn original method. Okay, not only A inverse, but also some other definitions. The first one is, this is from 10th class. If A is equal to 2 by 2 square matrix, say the elements A, B, C, D, then this is mod A, or some people read as det A, determinant A, is equal to product of the diagonal elements minus product of the non-diagonal elements. This is for 2 by 2 square matrix only, shortcut. AD minus BC. Next, adjoint of a square matrix denoted by ADG. I will tell the original meaning later. In 10th class method, shortcut method. Interchange diagonal elements. Non-diagonal elements multiplied by minus sign. Minus B, minus C. And everyone remember this formula for A inverse is equal to adjoint A divided by determinant A on one condition, if that A not equal to 0. Let A be a square matrix. 2 cross 2, 3 cross 3, 4 cross 4, anything, higher order or lower order, anything. So, 2 cross 2 order is simply read as order 2. A is a square matrix of order 3 means it has 3 rows, 3 columns. Order 2 means a matrix is of order 2 means it has 2 rows, 2 columns. Please understand like that. Then, number 1 in this, minor of an element Aij is denoted by Mij. And defined as Mij is equal to determinant of square submatrix obtained by deleting ith row and jth column. So if it is a 3 by 3 matrix, square matrix, take any element Aij. Aij means either A11 or A12 or A31, A22, etc. anything. So for that element, the minor is denoted by Mij. And how to find? Determinant of submatrix. Which type of submatrix? That submatrix obtained by deleting ith row, jth column. For example, if I take A12, what is A12? First row, second column element. First, immediately delete first row, second column. You will have a smaller matrix compared to given matrix A. That smaller matrix is called square submatrix in this case. So for that submatrix, you know how to find a determinant of a square matrix. So after finding determinant of square matrix, that means determinant of submatrix, that value is called the minor of this element. Okay, I will show an example later. Let me complete all the some other definitions. Number 2, cofactor of an element, where I am taking this Aij from square matrix only, given matrix, is denoted by capital Aij and given by, that means defined as capital Aij is equal to minus 1 whole power I plus j into Mij. So cofactor of an element is denoted by capital Aij, which is nothing but minor element, minor of that element multiplied by proper sign. What is the minus 1 whole power I plus j? It is giving either minus 1 or plus 1. So proper sign means for the previous minor answer multiplied by proper sign means either minus symbol or plus symbol. For example, if I take A12, so I value 1, j value 2. What is minus 1 whole power 1 plus 2? Minus 1. For that minus 1, what is the sign? Proper sign means minus. That minus into minor. Minor I already told you. So minor of an element multiplied by proper sign, which is called cofactor of that element. So for some elements, minor of that element is called cofactor of that element. For some other element, minor and cofactor having same numerically number but differ by sign. Okay. So A12, what is cofactor symbol? Minus. Okay. If it is A22, I value 2, j value 2. Minus 1 whole power 2 plus 2 is plus. So in that case, for A22 element, the minor is same as cofactor. If I take the element A22, its minor is same as cofactor because of minus 1 whole power 2 plus 2 is plus symbol. Okay. So finding all the cofactor, that means every element is replaced by cofactor and then transpose. The matrix so obtained is called cofactors matrix. That is also called, adjoint of a matrix. Every element is replaced by cofactor and then transpose. That is called cofactors matrix transpose, which is simply called adjoint of a square matrix A. Adjoint of A is denoted by ADJ. And given by ADJA is equal to cofactors matrix of the matrix A transpose. This is the definition. You know, in the previous step, cofactor. Every element is replaced by cofactor and then transpose. So this is the right hand side is once again a matrix. That matrix is called adjoint of the given square matrix A. Number 4. This is determinant definition. The sum of products of elements in a row or / column of A is called the determinant of square matrix A. So I missed that one word, kindly excuse me. With their corresponding cofactors is called determinant of square matrix A. So you know how to find cofactors. For example, all these definitions related to square matrix. First of all, remember, take any row, first row, second row, third row, any row or any column, each element multiplied by its cofactor, corresponding cofactor. That means if I take first row, there are 3 elements. After taking 3 by 3 square matrix, every row column containing 3 elements. First element multiplied with its cofactor plus second element multiplied with its cofactor plus third element multiplied with its cofactor. So that value obtained is called the determinant of the square matrix A. Of course, A is a square matrix. Okay. So similarly, if you take second row, third column, so whoever it may be, whatever the method you are using, determinant of a square matrix is a single answer, unique answer. Okay? While finding determinant A, if we get not equal to 0, okay, implies and implied, or you can write IFF language. A is called non-singular matrix. While finding determinant, if we have 0, implies and implied by, such a matrix is called singular matrix. Only non-singular matrix invertible. Okay. A square matrix, SQ means square, MAT means matrix, is called invertible if and only if or A. Okay. A inverse exists, that is that A not equal to 0. Simply, invertible means matrix inverse exists, that is called that A not equal to 0. This simple one more question also asked in 2019. So for all this, I am going to do one example, how to find inverse of a square matrix, taking a 3 by 3 matrix. Please go ahead. Example, This is 1994. A is equal to 101 minus 111 010. So first we have to find determinant A because of inverse. Don't find cofactors adjoint A and then second step det A. Sometimes if you find first step adjoint A, second step determinant A, if determinant A 0, then time waste unnecessarily. Okay. So usually selecting a row or column before expanding the determinant, the best row or column containing maximum zeros. Because if more elements are 0, then it is taking less time to simplify. 0 into anything is 0, that is why. So I want to select third row, expanding. So what is the cofactor symbols? What is determinant procedure? In a row or column, every element multiplied by its cofactor. Then sum. Sum means adding. Okay. So 0 into cofactor of 0. So here 0 into cofactor of this 0. Okay. Plus 1 into cofactor of 1. Okay. Plus 0 into again cofactor of 0. That is in a row, expanding by third row. Expanding by third row. Plus means sum of the into means product. Sum of the products of the elements with their corresponding cofactors. So this is 0 into, what is cofactor? Minus 1 whole power. This element is A31, I value 3, J value 1. So that symbol is plus into minor of an element is obtained by deleting the corresponding row and column, the remaining submatrix determinant. So 0 into delete third row, first column. What is the remaining 4 elements submatrix? 0, 1, 1, 1. Next, cofactor of this element 1. This element is, position is A32. I value 3, J value 2. So minus 1 whole power 3 plus 2 is minus. So minus into minor of this element is delete third row, second column. 1, 1, minus 1, 1. This is the submatrix. Minor means determinant. Okay. So determinant 1, 1, minus 1, 1. Next. This element into minus 1 into last element plus 0. 0 into what is the cofact? This element A33. I value 3, J value 3. So minus 1 whole power 3 plus 3 plus. So that is plus 0 into delete third column, third row. The remaining 4 elements submatrix which is the minor of this 0. So 1, 0, 1, 1. Sir, why are you writing this 0 into determinant? 0 into anything is 0. I know because this is the first example. I want to write each and every step. Okay. Some elements are non-zeros. In some problems, all the elements are non-zeros. So in that case, this method is helpful. Okay. So 1, 0 minus 1, 1. Now in this case, 0 minus 1 into AD minus BC, 2 by 2 determinant. That is the first definition of the previous one. 1 plus 1 plus that is 0. Simplifies to minus 2. Minus 2 value not equal to 0. When determinant not equal to 0, we are success. That is, we are able to find A inverse. When determinant 0, that is one of the options does not exist. A inverse does not exist. Now, finding adjoint A. What is adjoint A definition? Every element replaced by cofactors matrix A. Then transpose. What exactly this gives? Cofactors matrix means. So, you know the definition of cofactor. Minus 1 whole power I plus j into minor of that element. That is proper symbol multiplied by minor, the first element. So that's why in 10th class, in the textbook, the first example they have explained by putting the symbols plus minus above the elements. So this is A11, whose cofactor symbol is plus. This 0, A12, symbol is minus. Every row, first element taking 2 seconds, and the remaining elements symbols obtained by alternatively plus minus. And this is plus, and this is minus, plus, minus, plus, minus, plus. So where I put the symbols above the blue color elements, that is black color symbols, which is indicate minus 1 whole power I plus j. So this is number 1, first element. First, how to find cofactor? Proper sign symbol into minor of that element. Minor of this one, deleting first column, first row. This is the small matrix, submatrix. Determinant 1 into 0, minus 1 into 1. So minus 1 into plus, minus 1. This second element 0, delete second column, first row. So minus 1 into 0, minus 1 into 0. 0 into black color symbol, minus 0. Third element is 1. So symbol is plus, that is cofactor symbol. Into minor. Minor means deleting third column, first row. These are the submatrix 4 elements. Determinant minus 1, minus 0. So minus 1 into that plus, minus 1. Fourth element is minus 1. Deleting second row, first column. 0 into 0, minus 1 into 1. That means minus 1 into black color minus, plus 1. Fifth element is 1. Deleting second row, second column. 1 into 0, minus 1 into 0. 0. 0 into black color plus 0. Sixth element is 1. Deleting second row, third column. 1 into 1, minus 0 into 0. 1. 1 into this black color minus, minus 1. Seventh element is 0. Deleting third row, first column. 0 into 1, minus 1 into 1. Simplifies minus 1. Minus 1 into plus, that is minus 1. Eighth element is 1. Deleting second column, third row. 1 into 1, minus of 1 into minus 1. Simplifies 2 plus 2. Plus 2 into black color minus, minus 2. Eighth element is 0. Deleting third row, third column. 1 into 1, minus 0 into minus 1. Simplifies 1. 1 into black color plus 1. So finally transpose, which is nothing but minus 1, 1, minus 1, 0, 0, minus 2, minus 1, minus 1, 1. So therefore, A inverse is equal to adjoint A divided by det A. Okay, which is nothing but minus 1 by 2 into minus 1 1 minus 1 0 0 minus 2 minus 1 minus 1 1. So suppose options given, you can use by options method by using this note point. Verify A into A inverse is equal to I. Similarly, A inverse into A is also. When a matrix multiplied by its inverse, whose answer is nothing but identity matrix, compulsory. Your answer is correct or not, what is the best verification method? The given question A multiplied by the last step A inverse. If you multiply these two, if you get identity matrix, then your answer is correct. Otherwise, it's your mistake, done simple mistakes by finding determinant or cofactors. So, can I verify that? This is A. First row multiplied by first column in A inverse. 1 into minus 1 plus 0 into 0 plus 1 into minus 1 simplifies minus 2. Outside multiplication minus 1 by 2. So minus 1 by 2 into minus 2 is plus 1. Plus 1 is the first element of identity matrix. Let me check another element. First row in A multiplied by second column in A inverse. 1 into 1 plus 0 into 0 plus 1 into minus 1. Simplifies 0. 0 into minus 1 by 2, 0. Like that you can verify. Okay, if you feel difficult about cofactors. Anyhow, this is not a numeric question. This is multiple choice question. That's why they provide ABCD option. When the answer is option D, every option you have to verify like this, which will take more time sometimes. So in that case, the best method is definition method only. Have a break.